The second way that we can solve a linear system is to use a method called substitution. So the first method we learned was graphing. The second method is solving systems using substitution. So as an example, there's a word problem to start off, and that just kind of helps us understand that lines on a graph can actually represent real life situations. And this first situation is about somebody starting a muffin business. They have a startup cost of $200. The cost of making one muffin to the person running the business is 50 cents. Therefore, the total cost in dollars is represented by an equation that looks like that. So 50 cents per muffin and $200 is the startup cost. The second equation is a revenue equation. Each muffin they can sell for $1.50. So therefore, the revenue, when we're looking at an equation for revenue, would be C equals $1.50N. So what this question is asking is to determine the number of muffins that must be sold for the business to break even. Let's say this person, it's $200 to start off. The two equations might look something like that. These two lines are going to cross, and what that's called is the break-even point, where they've spent money to start the business and then all of a sudden they're going to start making money from selling muffins. What substitution is about is subbing one equation into the other. So for example, this second equation here, if C equals $1.50N, then in the other equation up here, it shouldn't matter if that's a C or $1.50N because they equal each other. So if we sub what C equals into the opposite equation, our new equation might look like $1.50N equals 0.50N plus 200. And then it just becomes a question of solving for n. What I want you to notice is in the first two equations up here, we had c's and n's. We had two different variables in each equation, and that makes it impossible to solve for a particular variable. Now when we look at the equation that we have written, the only variable in our equation is n. So in that way, we will be able to solve for n. So what we would do is subtract 0.50n from both sides, so that on the left-hand side, $1.50 minus 50 cents is 1n, and on the right-hand side, we just have 200. So what that tells us, it actually means something in this case. They must sell 200 muffins to break even. If we wanted to find the break-even amount, that is the C value. So if we use the same equation from the beginning, I'm just picking the simpler equation, and if we sub in the value of n being 200, it might look like $1.50 times 200. And when we do that, we get 300. So what that means is the break-even amount is $300. So when we look at solving linear systems by substitution, we know that we always have to isolate a variable, and then we substitute what that variable equals into the other equation. That's very important. We solve for the unknown, and then we substitute back into either equation. It doesn't matter at that point. And the coordinates x, y represent the point of intersection, or the break-even point for the linear system. So when we look at example 1, first step, like we said, is to isolate a variable. So the first equation, it's in y equals mx plus b form. The second equation also has the y isolated. So in the first step for us then would be to take the fact that if y equals x plus 1, then it should make no difference if we sub in x plus 1 for y into the second equation, into the opposite equation. So what that means is instead of this y, we're going to write x plus 1, because if y equals x plus 1, they equal each other. It makes no difference if we write a y or an x plus 1 in place of the second y. So in the second equation, instead of y, I'm going to write x plus 1, and then the rest of the line looks the same. And then it just becomes a question of solving for x. So we would want to move the x's to the same side. So we would add x to each side. And so on the left-hand side, we would have 2x plus 1 equals 3. And then what we might want to do is move the 1 to the right-hand side with the 3. So we would have to subtract 1 from both sides. And so 2x equals 2. And when we divide each side by 2, we get x equals 1. So if we're solving the system, we're trying to find out where two lines cross, we already have the 1. Now we just need to find the y value. So what we can do at this point, since x equals 1, you can sub that back in to either equation. It doesn't matter which one you pick. Normally what we would do is pick the one that looks easier. So to me, the first equation just looks easier. So if y equals x plus 1, we're going to sub in x equals 1. So y equals 1 plus 1, and y equals 2. So our final answer is, therefore, the solution is 1, 2. Okay, the next example, example 2. Same thing, we have a y that's already isolated. So what we might do is take whatever y equals and sub that into the opposite equation. So instead of y, we would write negative x plus 1, and then the 2x plus 4 is already there. You would want to collect your x's on the same side of the equal sign, so most often we might move the 2x to the left, which means that we would subtract 2x from both sides. And when we do that, negative x minus 2x is negative 3x plus 1 equals 4. And now we might like to bring the 1 to the right-hand side, so we're going to have to subtract 1. So negative 3x equals 3. Divide both sides by negative 3, and we get x equals negative 1. Now at this point, it doesn't matter which equation you sub this back into. Maybe the second equation looks easier because there isn't a negative sign. Let's try subbing it back into y equals 2x plus 4. But you really do get to pick. So if x is negative 1, 2 times negative 1 plus 4, so y equals negative 2 plus 4, so we get y equals 2. And always, just like with a graph, when you see where the two lines cross, we say, therefore, the solution is negative 1, 2. And that is where these two lines cross. And we found it without having to graph it. So the last example we'll do is example 3. Solve the linear system by substitution. So this time there isn't a variable that's isolated before we even start. So what I want you to do is always look for the letter that's the easiest one to get all by itself. And I think we could isolate this x right here. And if we did, we'd have to put the 5y to the opposite side of the equal sign. So it was a positive. We would have to subtract 5y. And we end up with x equals 3 minus 5y. So substitution means whatever x equals in the first equation, we sub it in for the letter x in the opposite equation. So 2y is already there, minus sign is already there. 3 minus 5y gets subbed in. When you sub in, you always put what you're subbing in a bracket. And we're going to have to use the distributive property right here. Negative 3 plus 5y equals 11. Collect the like terms, so the 2y plus the 5y, that's 7y. And then the 3, you'd want to move to the opposite side, so we'd have to add 3. And so 7y equals 14. And the last step, divide both sides by 7, so y equals 2. And if y equals 2, we might sub it back into either the first or the second equation, it doesn't matter. But I might sub y equals 2 into the first equation. So instead of the y, we're going to write a 2, which means that 5 is multiplied by 2. So x plus 10 equals 3. You would want to subtract 10 from both sides, so x equals negative 7. And you have found the solution to the system of equations.